Hello, everybody. So today we are going to look at exponential and logarithmic equations. So what we're going to do in this section is we're going to solve equations that are in exponential form that have the same basis and then in different bases. And then we're going to go into log form and then use our properties that we've learned over the past, week or so and apply those properties and to be able to solve these equations. So we're going to start with exponential equations. And so we're going to look at like bases. So what's going to happen is you're going to be given equations that have the same base or have the opportunity to be written into the same bases. And what that happens when you actually get the two same bases that are the same, what you're going to do is that you take your bases, you drop the bases and just set the exponents equal to each other. And then you solve the equation. So the key thing is here is whatever problems they give you, you have to put them into the same basis. Now, if for some reason you can't do that, in a few minutes we're going to learn a different way of doing it. But for this part here, we're going to be able to write these exponents into the same basis. So let's take a look at this. We have two examples here. So on the first one, I've got 5 to the 3x minus 6 is equal to 125. So now what I'm going to do here is right now my bases are not the same. So I have to make them the same. And the way that I do that is I say, okay, well, I can't turn this 5 into a 125. However, I can turn this 125 into a base of 5. So I'm going to leave this one alone right now as is. But I'm going to take my 125 and I'm going to turn it into a base of 5 by going 5 to the third. Now, this is exactly what I want. So now what I'm going to do is I'm going to come over here and say, okay, great. I got exactly what I wanted. My bases are the same. So I'm going to drop my bases and set my exponents equal to each other. And then I'm just simply going to solve the equation at this point. Move that 6 over and divide by the 3. Okay. So what this is saying is when I take that 3 and plug it into here, I get 3 times 3, which is 9, minus 6, which is 3. So 5 to the third is the same thing as 125. So that's all you're doing. You're just solving to figure out what is that x value that goes in there to make this side be 125 because that matches that side. Now, this is where they gave you the base and then you have to change the other one into the other base. But what happens when you have this problem here? Now, a lot of you are going to go, oh, you just take the 4 and multiply it by 2. No, you do not take the 4 and multiply it by 2. That does not give you 8. What you have to do is you have to say, okay, what bases does 4 and an 8 have in common? Well, obviously 4 squared gives me 16. And so that means I can't get to that 8 that way. However, I can go the route of the base of 2. Because 2 cubed gives me 8 and 2 squared gives me 4. So what I do is this. I'm going to take my 8, and 8's really the same thing as 2 cubed. And then I still have that x plus 2 I have to deal with. That 4 is the same thing. Oops, not 4. That 4 is the same thing as 2 squared. And I still have that x minus 3 I have to deal with. So now that I have them both set with the same base, what I'm going to wind up doing is just dropping the bases. And now I have this linear function that I'm actually going to have to be able to solve and get my answer with. Now I just clean up. So 3x plus 6 is equal to 2x minus 6. I'm going to move my 2x over here. That gives me x plus 6 is equal to negative 6. And then I'm going to move my 6 over there, so I get x is equal to negative 12. And that's what is going to go in there. So basically, this is saying when my x is equal to negative 12, that is when these two equations are equal to each other. It is okay. Sorry. It is okay for your exponentials when you're solving these to get a negative x value. That is absolutely okay. What can never happen is that your base can never be negative. So just keep that in mind. All right. but having an x value that's negative is a-okay. So in your homework, you're going to have something that looks like this. So what I want you to do is I want you to take a few moments, pause the video, and see if you can solve this equation. And go. All right, welcome back. So let's see how you did. So if you did this correctly, you wound up with that. And then if you keep going, you get this, which means that your x is equal to 8. And that's what you put in there. Okay? All right, so moving on. So what happens when your bases are not the same? So when your bases are not the same, you're going to have to do something different. So it just depends on how you want to approach the problem. I tend to like to lean towards this one here. To me, it's just a little bit easier, but it just depends on what problems they are giving you to begin with. So what's going to happen is they're going to give you they're going to give you an equation, and you're not going to be able to write one side in terms of the base of the other side. So what you're going to need to do is take the natural log of both sides and then go through there and use your properties and solve the question that way. So let's take a look at what I'm talking about. So I have 5 to the x is equal to 134. Now, I can't do anything with this at all because there's no way I can write each other in terms of the other. So what I'm going to want to do is I'm going to take the natural log of both sides. And what that means is this, is I'm going to take this 5 to the x. I'm going to say the natural log, get a pen that actually works. I'm going to say the natural log of 5 to the x. And what you do to one side, you have to do to the other. And the natural log of 134. So now what this does is now I can start applying properties and I can undo this piece right here, which is what I want. I have a property that says if I have an exponent, that exponent comes down into the front. So then I come over here and say that x natural log of 5 is equal to the natural log of 134. Now, what you have to remember, this natural log of 5 is actually a number, so treat it like a coefficient. So if I'm going to treat this like a coefficient, how do I get this x by itself? I'm going to divide both sides by the natural log of 5. And when I do that, I wind up with x is equal to the natural log of 134 over the natural log of 5. And that is my final answer. You can put it into the calculator and get a decimal value. Pay attention to what it's asking you to see if it wants you to um, like round to like the nearest tenth to the hundredth or whatever else. So just pay attention. Okay. So let's try this again. We have 10x is equal to 8,000. All right. So the same thing is going to happen. What you're going to do is you're going to go through here and you're going to do the same thing that we just did. So I'm going to say, all right, I got the natural log of 10 to the x is equal to the natural log of 8,000. Follow my property. That x comes in the front. And then I have that piece right there. And then I divide by that natural log of 10. So I wind up with this over that. And again, if you need it in decimal form, because your equations might ask you to do this in decimal form, I'm going to say alpha y equals 1. I'm going to say the natural log of 8,000 over the natural log of 10. And it usually asks you to roughly about 2 decimal places. So I'm looking at this. So this is approximately, oops, approximately 3.9. Okay? So now, what happens when you have this? The same exact thing is going to wind up happening. So you're going to take the natural log of both sides. So we have the natural log of 3 to the 2x minus 1. And the natural log of 7 to the x plus 1. So the same thing. Natural log both sides. This is an exponent. So this comes down in front. But now I'm going to develop parentheses. I'm developing these parentheses because I have more than one term here. Okay. So now I've done that. So now what I need to do is I can't divide like I did last time. So what I need to do is I need to distribute this natural log of 3 here and here, and this natural log of 7 here and here. So I have to be able to do both. So when I do this, I wind up with 2 natural log of 3x minus the natural log of 3 is equal to natural log of 7x plus natural log of 7. All right, now you're thinking, oh my gosh, this is a hot mess. I don't know what to do. Okay, don't panic because this is the easy part. What you want to do is anything that has an x, you want to move it to the left side and everything else goes to the right side. So I'm going to rewrite. So I got 2 natural log of 3x. And I'm going to move this piece over here minus the natural log of 7x. And that's going to equal the natural log of 7 plus the natural log of 3. Now, what you need to notice is, okay, this makes a little bit more sense because now what do you notice? Well, they have an x in common. So I'm going to pull out that x. This leaves me with 2 natural log of 3 minus the natural log of 7. I keep my other side as is. And now I'm gravy because look, I have my x. I have this. This is a number. Don't forget, this is a number. So I have this coefficient sitting here. So I'm just going to divide both sides by my really odd looking coefficient. And so I wind up with this right here. Oops, almost wrote just 7. Natural log of 7. And there you go. Okay. So when you go through these, just take your time, space it out or whatever else, but pay attention to what you're doing. Okay. So these are what your homework questions are going to look like. So again, on this one up here, all you're simply going to do is take the natural log to both sides. And then you get that. Oops, not a 27. That's a 23. My bad. And then you're going to follow your property. And then you're simply going to divide. Let's see, use a calculator to obtain a decimal. So it looks like, so I think what's going to happen is that you're going to put this answer into here. And then once you get that answer, then you're going to wind up coming through and getting your decimal value for the next box or whatever else. So you're going to have to do the same thing down here with this one. So when you go through this process, then you're going to have to take a look at, making sure that you distribute that natural log all the way out and that you are going to have to make sure you put your x's on one side and then get your numbers pulled out and everything else and go from there. Okay. All right. So let's move on to log equations. Okay. So when you look at log equations, what you need to do is remember you have all those log properties that we did. So when we did those log properties, what we want to do is that we want to express the equation into this format here. So we want to take our properties and we want to condense. So if you have multiple logs, we want to condense it down into one log. So that way we can use our log properties that we did to be able to actually solve these. Because what's going to happen is you're going to take it from this format here once you condense it. So that way you can turn it into this piece right here. So that way, I mean, unless it's where you may not have to take this step, because sometimes you can like take it from here and then just be able to solve it. But sometimes what you're going to have to do is take it into this piece here, so that way you can actually get your answer. Now, the key thing is when you deal with logs is this piece right here. Check the solution, because remember, you have to have positive answers. Your x value can be negative. That is okay. But when you take that x value and you plug it back into the log equation, if it makes that inside go to a negative number, you can't have that. So you have to make sure that you have you are getting positive answers. So here we go. We're taking a look at this piece here. So I've got log base 2 of x minus 4 is equal to 3. So when I'm looking at this, I'm already in a single logarithm and I have a coefficient of 1. So that's a good thing. So what we're going to just need to do here is we're going to say, okay, well, what I want to do is I want to go ahead and rewrite this. So let's see what happens when I rewrite this into an exponential format. So when I do this, you have to remember this is my base, this is my exponent, and this is the m value that we're actually going to wind up doing. So I get 2 to the third is equal to x minus 4. Ooh, this became an easy problem. Okay. So then I say, all right, well, I have 8 is equal to x minus 4. Okay, that's good. Move my 4 over. I get a 12 is equal to x. And there you go. So I need to make sure that this is going to work out correctly. So what happens is I say, all right, well, I have log base 2 of 12 minus 4 is equal to 3. So I have log base 2 of 8 is equal to 3. So then when I change this around, I get 2 to the third is equal to 8. 8 is equal to 8. So this is a true statement. So I have done everything that I needed to get that done. So usually in these ones, those are going to be kind of the easy ones. So that way we can take a look at it and, it's one log. It's just kind of like one of those one and done problems. And so you just rewrite it to the exponential form and you just keep on going from there. And usually you're not going to have anything that's out of the ordinary. It's, I think it's one of the couple problems maybe I have later on that you might actually have to worry about. So let's take a look. Oh, yeah. So like this one here. Actually, I think, yeah, we just did this. So in your homework, it's going to look like this. And notice it says, be sure to reject any value that is not in the domain. So when you go through this piece right here, I rewrote it, wound up with 2 to the third is equal to x. So you have to take this and you'll have to take what that looks like in exponential form, because it says rewrite the given equation without logs. And then remember, it says do not solve. So I do that, and then it'll pop up the second piece where it says, okay, now solve it. So that's what you're going to do right there. All right, so now let's take a look at this one here. So I've got 4 natural log of 3x is equal to 8. So I come over here and say, okay, well, I don't want to do anything with this yet because I have this piece right here. So when I have this piece right here, what I want to do is I need to go ahead and to divide both sides by that 4 first because I need to get that natural log by itself. So I actually am looking at this piece right here. So what I want to do from here is saying, okay, so now what? I'm kind of stuck. Well, no, not really, because what you're going to do is when you're dealing with natural logs, so make a note. So when dealing with the natural log, you're going to raise both sides to E. Oops. To E. Okay. So what that means is I'm going to say, all right, that's what you're asking me to do. You're telling me to do this. E to the natural log of 3x is equal to E squared. That's what I'm asking you to do. That's what that is what this little green spot right here is telling you to do. It's telling you to take this piece here, raise both sides to E. Because once that happens, then you have a property that you can use. So remember, your property said, okay, if I have E to the natural log, so my answer is just simply going to be written right here. So I can simplify just this side, and I wind up with 3x is equal to E squared. And so now that I have that, the 3x is equal to E squared, then I can just solve this simply by saying E squared divided by 3. So this is only when you have a natural log because it's simpler. There's a different way of doing it, and that's fine too. I think no, I'm right. So when you get to this step here, you can put it into this format because remember, I'm gonna go back a few slides here. Nope. Where is it? Must have been a couple of slides back. I didn't realize it was this far back. Because remember, if you can get it into this format right here, that's actually what we're trying to figure out, what you're trying to find. Is so if you can be able to write it into that format, or if you can write it into the format of the E to the natural log of X, you can do that too and still wind up with the same answer. All right. So now, looking at problems that look like this. So when you're doing this one, it's the same thing. You still want to be able to condense so you have that one log that you're actually dealing with. So notice right here, I have this piece right here. Well, that means I have the product rule I need to deal with. So what I'm going to do is I'm going to take that and I'm going to say, all right, really this is log of x and then x minus 3 is equal to 1. All right, so now that I've got this, remember there's a base 10 sitting here. So I have 10 to the first is equal to, and I'm going to go ahead and distribute this, x squared minus 3x. All right, that's fine. So now you have an equation here that's a quadratic. So this is where you absolutely have to check your answers. On the linear ones where you didn't have that, you don't have to worry about checking your answers as much because usually what you get is what you get. On this one, however, you have more error possibilities to happen. So I need to solve this quadratic. So I'm going to move this over. So I want x squared. I don't like that too. I'm going to wind up with x squared minus 3x and then minus 10. So that's going to be x minus 5, x plus 2. So I wind up with x is equal to 5 and negative 2. So what I need to do is I need to take these and plug them back into the original equation. And if either one of these go negative, I can't use that solution. So when I take that 5 and plug it into here, I have a positive x, and I take it and plug it into here. 5 minus 3 is 2, so the 5 works. So far, one of my solutions will be 5. When I take the -2 and plug it into here, oops, I can't have a log of -2. It's just not going to happen. So because I have that, the only thing I wind up happening or having here is just going to be the 5. So my solution set is simply going to be that. Okay? Because remember, you cannot have a negative log. All right. We're going to use some more properties here. So when you have logs on both sides, the same thing that you're going to kind of want to do. So what's nice about this is if you have logs that are on the left side and the right side and they have the same base, just like what we did with the exponentials, you can drop those logs and set your m and your n equal to each other and solve that way. But again, on these ones, again, you're going to have to check because you have to make sure that both your m and your n remain positive. And sometimes you're going to go through these and you're not going to have any at all that wind up having a solution. Okay, so before I get into that one, a couple of things that you need to note. So you do have 3 possibilities here. So your first possibility is you will have solutions. And you could have 1 solution, 2 solutions, depending on whatever it is, okay? The second possibility is you have no solutions. So that's when you plug in your x values and both of your answers make one of the logs go negative, and you can't have that, okay? The other possibility, and this is, kind of one of those rarities, is when everything cancels out. So the left side equals the right side, like legitly equals the left and right side, and everything cancels. And you wind up with a 0 is equal to 0. So when that happens, you have an infinite amount of answers. So when you go through these things, these are the 3 things that you're going to have, and these are the 3 things that you need to be aware of as you do it. More often than not, your answers are going to lie up here, and you just have to check to exclude your values. But you do have these other options down here. So now, back to this. Natural log of x minus 3 is equal to the natural log of 7x minus 23 minus the natural log of x plus 1. So when you're looking at this, you're saying, okay, this is a lot of natural logs. Well, remember, you have properties. We want to make sure we have the same base on both sides. Luckily, with natural log, you're already in the same base, so there's not much that you need to do. So what the first thing we need to do is use our properties, however, and take that and make it to one really big natural log. So I got to that natural log of x minus 3, and that equals the natural log of 7x minus 23 all over x plus 1. So this is a good thing. Because I have this, I can now drop my natural logs, and I can say, all right, I've got an x minus 3 over 1. And that's going to equal 7x minus 23 all over x plus 1. So now what I'm going to need to do is cross multiply these. So I wind up with x minus 3, x plus 1 is equal to 7x minus 23. Clean up the left side over here. So that's x squared minus 3x, so it's minus 2x. And then minus 3 is equal to 7x minus 23. I'm going to move everything to one side. So I've got x squared minus 9x plus 20 is equal to 0. So that gives me x minus 4, x minus 5. So my x values are 4 and 5. So I need to take my 4 and 5 and come back up to here and plug everything in and make sure everything is going to be positive. So when I take my 4, that gives me a 1 here, a 5 here, and a 5 here. So 4 is one of my solution sets, which means that when I take the 5 and do the same thing, I get positives all the way through. So therefore, my solution set will be both 4 and 5. They both work. That's a good thing. Life's good. I can move on. All right. So take a few moments, pause the video, and let's see how you're going to do on this one. Okay. Again, make sure that, your bases are already going to be the same, and you're going to drop your bases and then solve that equation, and then make sure you check your answers. Okay. So ready, go. All right. Welcome back. So let's see how you did. So we have log of 5x minus 3. So I'm going to take this and I'm going to use my product rule. So that gives me log of 6 times x plus 1. So then I can drop my logs because they're both the same base. And that gives me 6x plus 6. I'm going to move that 6 over here. That gives me a negative x. Move that 3 over here is going to give me a 9. So x is equal to negative 9. All right. So then I take that negative 9 and I come up here and say, all right, so I'm going to plug that negative 9 into here. So that gives me negative 45 minus 3. Oh, no, can't have that. So that means that there's going to be no solution. Okay. Because remember, if one of your logs go negative, that's it. You're done. You cannot have a negative log. All right. So just a quick recap. When you solve exponential equations, you must have like bases. If you do not have like bases, use natural logs to make both sides equal. When solving log or natural log equations, remember they need to be positive. That's the key. They have to be positive. This means you have to check your answers to make sure that when you evaluate for x, you find out that your natural log or your log is not negative. Okay. So those are the 3 things you need to make sure that you are doing when you are solving these equations. Make sure that if you have any questions, you are sending me a remind, you're sending me an email. Just hit that little ask the instructor button on the side if you get stuck or whatever. But for the most part, that is exponential and log equations. So now go get your homework done. And again, if you have questions, make sure you're getting in contact with me. I hope everybody has a great day, and I will talk to you soon. TTFN. Ta-ta for now.